Welcome to this presentation of what makes a good CGE research paper. This presentation typically comes towards the end of the short course when participants are beginning to think about next steps and how they might proceed with their own research. There have been prior contributions on this talk, and those individuals developing some of this material are acknowledged here. The first thing you need to determine is who's your audience. So is it a policy report? Is it an academic journal article? If it's a journal article, is it for a policy-oriented audience or a methodology-oriented audience? This is going to be a critical decision. This will determine how much emphasis you put on the policy side, how much you put on the novelty of your approach, new theory, methods, and so on. You really can't get very far down the stream without determining your research question. So often I'll be sitting in on a PhD prospectus defense, and I find myself asking halfway through the presentation, what was the research question again? There's a tendency to get fascinated with the methods and forget about the research issue. The research question needs to be foremost in your mind. Having determined that, you also need to think about what the key outcomes are likely to be, the metrics which will address this question, whether it has to do with regional welfare, distributional impacts, environmental impacts, and so on. Another key step is identifying the analytical issues. This is in the context of general equilibrium. A key question, you need to think about aggregation. What kind of aggregation is needed? What's the minimal aggregation needed to draw out the question that you're interested in? So there may be the subsidized sector and the unsubsidized sector. There may be the polluting sector and the non-polluting sector. These things need to be determined and will influence your breakout of commodity markets and factor markets. Market structure is obviously important, whether there's scale economies present, whether variety effects make an important contribution, market power, and so on. Quantity and price rigidities are often very important as well, and these will be determined through your model closure. There are 4 steps that I want to emphasize in this analysis process. The first step is you're just beginning to think about the problem and you want to sketch it out. Well, why not do a sketch? Why not draw a picture of the simplest possible economy that has the essential features to the problem? So there may just be 2 sectors in your picture, depending on the number of regions in question, you may have 2 or 3 regions. But getting this picture down on paper is a good start. Here's an example of the case of biofuels. There are 2 pictures. One is the economy without biofuels, and so we're talking about first-generation biofuels. So basically, cropland is used to produce the crop. The crop is used by various food sectors, including livestock. In panel 2, biofuels enter in and play a role in creating a further demand for crops, and potentially emphasizing competition for cropland with these other uses. Having sketched out some of the key elements on paper, it's useful to turn to mathematics and see if there's some simple analytical results available, albeit for likely a restricted version of the model. This allows you to identify key parameters, what your expected results are going to be qualitatively, and I've got an illustration here for the biofuels case. This is from a paper published in the Energy Journal. It uses a partial equilibrium model to think about the growth in the ethanol output over a period in the early 2000s when this sector was booming. And there were really 3 factors behind that boom. One has to do with this additive intensity, and due to the banning of another fuel additive, ethanol became the preferred additive and generated a big shock, so a big percentage change in AI here. Another factor was the price of energy or fuels in general going up very strongly with the price of oil. So P was going up as well, and subsidies were being implemented. That's the variable S. So this combination of things was driving output, and this just shows you in partial equilibrium how the various parameters in the model, including the substitutability between ethanol and petroleum, the share of the ethanol going to the price-sensitive side of the market, the supply response of the feedstock, all of these things play a role in determining how much output increases. So in this case, we used this expression not just to understand what was going on, but actually to obtain a preliminary estimate of sigma, that elasticity of substitution between ethanol and petroleum. It turns out to be a central feature in this problem, and we used this partial equilibrium model to figure out what size of sigma was compatible with the observed increase in output. So playing with this kind of analytical model can be very helpful as you focus in on a particular sector of interest. The CGE model is only as strong as its partial equilibrium components. I believe this point very strongly. Just because we're doing CGE modeling doesn't mean that we don't have to pay attention to partial equilibrium modeling. We do have to do that. We have to communicate with the PE modelers, maybe do some of it ourselves. There was a great debate in the 70s, the early 70s. Jay Forrester was working on some complicated systems dynamics models which were predicting basically an area of great resource scarcity and kind of a Malthusian view of the world. And they emphasized the interactions amongst things. And you often hear CGE modelers using the same argument. But so Forrester said, rather than going to the bottom of any particular problem, what we want to look at are the problems caused by interactions. Robert Solow, a Nobel laureate in economics, responded, I don't know what you call people who believe they can be wrong about everything in particular, but expect to be lucky enough to get it right on the interactions. They may be descendants of the famous merchant Lapidus, who said he lost money on every item sold, but made it up on the volume. You simply can't have a good CGE model that doesn't have good partial equilibrium components. Excuse me. So the next step, having gone through these preliminary steps, identified key features of the problem, the next step is to extend it to the full-blown CGE analysis, to relax assumptions, bring in additional complexities as needed. In the biofuel case, some of these complexities had to do with, for example, byproducts. The process by which ethanol is produced turns out produce something called a byproduct called DDGS. DDGS substitutes for corn in feed. So the ethanol production process doesn't exhaust the feed value of corn. As a result, you can overstate the impact of on corn markets of an ethanol expansion. Also, you can understate the impact on livestock, which is benefiting from this low-cost feedstuff. So this requires bringing in the livestock sector, potentially bringing in trade in livestock. There's also a question about domestic and foreign demands, how well they substitute, possible importation of feedstocks, the competing uses for land. If more cropland is used for ethanol, where's that land going to come from? Will it come from forestry, which may have a very high emissions factor? The interaction with other policies and distortions, for example, agricultural policies, supply and demand conditions in the energy sector. We need to think about how this interacts with the oil economy as well. So all of a sudden, we're in a general equilibrium environment. So this requires a more complex picture. This isn't the full complexity here, but it's enough to show you that things do get more elaborate. Here we've got the biofuels generating byproducts, the byproducts going into feed to livestock, and competing with crops there. Panel 4 we have additional sources of demand, and of course we have these issues of land competition. So as you begin to think about your CGE analysis, you need to think about what is the appropriate aggregation to use. So I think once you've really pinned down your research question and you know what audience you're addressing, the aggregation often becomes quite clear, but you obviously need to have regions broken out, the countries of interest, the commodities of interest, and of course it's a general equilibrium model, so you've got to aggregate the rest of the economy in a meaningful way. Very important to look at the GTAP database and documentation. Often, while the database may appear to have a full 57 sector representation for some countries, those 57 sectors have been derived from a smaller input-output table, maybe 20 or 30 sectors, and you need to study those mappings and see how much real information is in your database. What about the tariffs? What about the base period of the data? You may need to run a pre-simulation. In fact, it's very common to run a pre-simulation before you undertake your actual study. You may be simulating moving the economy forward, say from 2011 to 2015, in order to update the relative sizes of the economies, policies, and so on. Or you may simply feel that the base data in 2011, for example, were wrong and needs to be corrected. This requires a different approach, and there are tools for this: alter tax, adjust tax rates, GTAP adjust economic flows. Both of those can be relevant. You don't do a normal model simulation there. You adjust the data before beginning to work with the model. What's your experimental design? It's very important to think about experimental design. A poor experimental design won't really answer the question you're asking, or won't answer it in a compelling way. So you need to think about that, and it can be quite complex. Are you going to shock policies one at a time? Are you going to study their interactions? Is you going to be looking at deviations relative to a baseline? Do you need to simulate that baseline? There are many questions to address and lead you ultimately to which variables you're going to be shocking. And of course, along the way, you can use the subtotals feature to figure out which of those shocks is most important in determining an endogenous variable. The closure and parameter values are obviously also important, and it's important both to draw on relevant econometrics literature and potentially to engage with colleagues doing econometrics to get better estimates of the one or two key parameters for the problem at hand. Model validation is something increasingly demanded by policymakers as well as journal reviewers. It's impossible to validate the entire GTAP model. There are too many exogenous variables that are unobserved and too many endogenous variables that we may also not have information on, or we may simply not be able to track. And as a result, validation, you need to be a little more creative than, say, the folks doing the standard econometrics. Here you need to think about what are the critical elements for the problem that you're addressing. And I'll focus on an example here in the energy area, but this could be applied in other areas as well. The one I have in mind has to do with the GTAP-E model, GTAP energy. This has been used a lot over the years to look at carbon prices or cap and trade quota systems, whereby the goal is to reduce greenhouse gas emissions. And the most important, kind of the first line of defense for an economy faced by a carbon price is to substitute away from that, to conserve somehow fossil fuels, the main source of emissions in the economy. So this is determined. Your model this can be summarized in your model as the general equilibrium elasticity of demand for energy. So once everything is adjusted, all the substitution has occurred, the expansion effects, consumer adjustments, income effects, that all gets summarized in one sufficient statistic, and that's the general equilibrium elasticity of demand for energy. There's a chapter on this in the GTAP book who want to know more about that. So this elasticity is going to determine really the outcome, the impact of this carbon price. And we were interested in studying whether this was appropriate or not, the GE demand elasticity in the GTAP-E model. Did it give reasonable results? So we tested this in two ways. We looked at historical simulation, from the 2001 to 2006, a period of rising energy prices. We looked at quantity responses. We also did a stochastic simulation where we simulated historical shocks to supply and compared price changes. So the historical simulation, we had to shock population, labor endowments, capital, investment levels, TFP, and by implication GDP was determined. And the model said at flat prices, global consumption would have predicted global consumption would have risen. But oil prices over this period rose by 154%. As a result, the model predicted actually that quantity of oil consumption would contract, and that's the top panel on the right-hand side. So we move from QO to Q prime. So even though demand's shifting out, the demand is elastic enough that with that price increase, output and equilibrium output fell. But in fact, what we observed over that period in terms of total consumption was that demand rose in most regions, so that it must be the case that the demand curve is steeper, as in the bottom right-hand panel. So a steeper demand curve, smaller elasticity, would seem to be more consistent with history. So we wanted to further explore this question. Was the GE demand elasticity too large in the model in absolute value? Was the demand curve too flat? To do this, we looked at, we did a stochastic simulation of the model. And here we used the systematic sensitivity analysis facility in Run GTAP to sample from historical distributions of exogenous shocks. These are both on the demand and the supply side in the oil market. So GDP was shocked as well as oil supplies. And the model then reports a distribution of oil prices resulting from that historical distribution of exogenous shocks. We can compare that, in particular, compare the normalized standard deviation of those oil prices to those observed historically. So historically, that normalized standard deviation was about 8.2%. The model generated a much smaller normalized standard deviation of oil prices. That is consistent with a too flat demand schedule. So as a result, the lead author on this work, Jason Beckman, went back, studied the literature, and found that, lo and behold, the price elasticity of demand in most uses was quite a bit smaller than in the GTAP-E model. When he incorporated that into the GTAP-E model, the modified model gave a normalized standard deviation that was much closer to the observed historical component. So the model failed. It failed in an interesting way. It failed in a way that allowed us, that informed us what changes need to be made, and when they were made, it performed much better. So that's a form of model validation that was proven useful in that case. So analyses, once you've got the results, analyses are not equal to big tables of results. So that's one of the first points, whether it's a journal reader or someone sitting in your class presentation or your seminar, they don't want to see big tables of results. You need to dig, and look for insights. So the way you undertake analyses is greatly facilitated by Analyze GE, because Analyze GE brings you right into the model, into the equations of the model. It assembles values for data, parameters, and shocks, and lets you see exactly what is driving the results. So in addition to Analyze GE, there's some very useful back-of-the-envelope calculations around. The master of this is Peter Dixon in Australia. I encourage you to look at some of the back of the envelope calculations that are available out there. But typically, you're looking at equations, either parts of the model or summaries of the model, and looking to understand what's driving the results. You're very likely to get unexpected results. Now, what do you do in this case? Do you simply cave in and say, well, those aren't what I expected, I'm going to redo it or change some assumptions? I would argue that's the wrong approach. What you want to do, first of all, is make sure that you've done everything correctly, because it's easy to make errors. But once you've done that, if the surprise persists, I think it's worth further investigation. Indeed, if this surprises you, it might surprise the journal reviewer, it might surprise and result in a publication, it might surprise the policymakers and shed light on an unforeseen side effect of the policy that you're examining, which could be very valuable. So you've got to stick to your guns. Don't immediately cave in if you get a result different from other models or different from your prior expectations. Pictures are very important. Graphics for presenting results. It can really be worth 1,000 words. I'll just show you a few examples, largely drawn from my experience working with people in the natural sciences. So here, working with some energy systems people, we did a study of biofuels, and the main concern was cropland conversion. This is a paper published in Bioscience in 2010. And the panel on the left, the figures on the left, nicely show you where the cropland conversion occurred and what land that was coming out of, which had a key implication for the level of CO2 emissions from that land conversion, which are shown in the bottom panel. On the right, you see a nice graphic reconciling this study's results, which were the far right-hand bar, with people's expectations, which was the left-hand bar. So if you just do the simple arithmetical calculations about how much land was needed to feed this biofuel boom, in this case in the US for ethanol, you came up with a left-hand bar. And this shows you, one arrow at a time, why our conclusion was much smaller. It has to do with resource constraints. That's the fundamental to general equilibrium. The co-product or byproduct question that I mentioned earlier brings the land use down further. There's the response of demand, consumers to higher prices. That brings the land use down further. There's the yield response. And finally, there's a question of productivity of new cropland, which was a bit lower and therefore boosts the amount of land conversion. So in the end, this was a very nice way to explain why, to readers, why their preconception about the amount of land conversion required for this ethanol production was perhaps misguided. Here's a study of poverty impacts of climate mitigation. This is something that hasn't been investigated that extensively, so there was keen interest in this. And the problem is that in this version of the model, this is the GTAP poverty model, and it breaks up the households in each region into 7 strata based on their earnings. So there's a stratum in red, which is agricultural self-employed households. There's a stratum in blue, rural labor, and so on. So each region, which are shown across here, the labels have been omitted, but each of those bars relates to a region, and each has 7 bubbles associated with it. The bubbles show what's happening to the individual strata. The size of the bubble shows how big the contribution of that stratum to poverty in the initial database. So if a big bubble moves a lot, that's going to tend to move national poverty. National poverty is shown with the gray bars. You can see that on average, poverty seems to be increasing due to these mitigation policies, and that's a concern. So this conveys a lot of information in one slide. Wherever possible, it's important to include error bars in the sciences, but also now increasingly in economics. Reviewers want to see 95% confidence intervals on results. This is an example related to the impact of technological change in agriculture on, in particular in sub-Saharan Africa, on terrestrial carbon emissions. And you can see that under a segmented market scenario, this appears to be emissions saving, at least at the world level. And on the right-hand panel, it shows with integrated markets, it's a very different outcome. So readers want to know whether a given result is significant or whether it's just a number that's not really different from zero. So these are generated by sampling from a distribution, from distributions on all of the key parameters in the model. There's another interesting approach that we've used recently, and that's the idea of placing other findings within a distribution of results. This is focusing on crop price changes over the period 2006 to 2050. So a positive number means crop prices go up, a negative number going down. So that this paper was published in 2016. I would say 2012, 11, 12, 13, there was a lot of concern about food prices, a lot of concern that food prices would be rising indefinitely into the future. What this Monte Carlo distribution of results from a simple model, which we term an emulator, this shows that when we sample from the distribution of parameters and underlying drivers such as population, we obtain a distribution of price changes that where the bulk of the mass is on the left-hand side of zero, suggesting a price decline, not a price increase. So perhaps that new normal consensus was misguided. However, you do see that some combinations of parameters are consistent with the models that showing high price changes, such as GTAP and AIM, but those are in the tail of this distribution. So this is a nice way of putting a variety of studies in perspective in the context of your own study. There's a very nice tool called the Morris method, which helps you evaluate the relative importance of different sources of uncertainty in model outcomes. So if we're interested in crop price, for example, the list of 17 factors here, there's 17 things in this model, both parameters and drivers of change that contribute to uncertainty in 2050 crop prices. And they're ranked from top to bottom here. So total factor productivity in the crop sector is the most important source of uncertainty. Narrowing that will narrow the uncertainty in crop prices in 2050 the most. There are some that aren't very important, and there's some that you may not have thought of that are important. So it's a useful way of understanding sources of uncertainty in your results. I'm a strong believer in teaming up with statisticians and econometricians. I have great admiration for their work, and too often CGE modelers seem to be at odds with econometricians. In fact, they have a great deal to contribute to what we do, parameter estimation foremost among that, but we can also be very useful to them. This just illustrates a study that was done, led by Frances Moore, and she created a meta-analysis of climate impacts results in agriculture. These were then placed on a grid, and using something called pattern scaling, she developed a pattern of yield changes for each of these crops over the globe. These then could be aggregated up to units within the GTAP model. So this is a very straightforward GTAP application. It's one in which you're shocking productivity in the crop sectors and eliciting then the various components as well as the of welfare change, as well as the total welfare change in terms of equivalent variation. So the one map A shows the direct effect or the productivity effect. The next B shows the terms of trade effect. C shows the allocative efficiency effect, and D the total effect. So this comes right out of your welfare decomposition. So a very straightforward application of GTAP, but a very useful one in this study in particular, has something important to say about the social cost of carbon, and you're welcome to read that if you have further interest in it. So there are going to be limitations to whatever study you do. Any model is wrong. Okay, there is no model that's absolutely right. The question is, does it provide insights? Does it teach you some things or remind you of some things you'd forgotten? And so I think acknowledging limitations, doing extensive robustness checks, very important now, especially in terms of publication, the academic literature, that to make sure that these results are robust. One word to the wise, when you receive reviewer feedback, go the extra mile. Don't minimize your effort. That's not the time. You spent all that time developing the paper. The reviewers have spent a lot of time reading it. Don't shortchange everyone at this point. You need to take each and every response carefully. Even if you don't think a factor will be important in determining your results, the reviewer thinks it may be, try it out. Show them that it isn't. Don't leave anything to guesswork, and make sure they feel like you've heard their comments and responded extensively. Other take-home messages, building the model is just a starting point. Using it and conducting analysis is the bread and potatoes, the meat and potatoes of what you're about here. Organization is very important to be organized and go one step at a time so you can see how each addition to the model affects your results. And teamwork, we're great believers in teamwork in the Center for Global Trade Analysis here. That's been a key to the success of GTAP. It's important to know when to cut off unproductive lines of analysis, when you're pushing on a string, just not getting anything out of it. Maybe it's time to drop it. More complex models are not always better. So this KISS principle, keep it simple, is one that is worth reminding yourself of from time to time. And of course, there are many questions that cannot or should not be analyzed using a CGE model. It doesn't mean you can't use this framework to think about it. In fact, you might start out thinking about it with a picture, with some analytics. Think about what are the key determinants, and you may decide in the end, well, it's probably not a CGE question. I can analyze this in partial equilibrium. That's great. That's fine. What you're taking away from this course is the framework in your head, and that's the most important one. Finally, I'd like to close with a very useful quote from Robert McDougall. This is taken out of GTAP working paper number 5, Uses and Abuses of CGE Analysis. It's a very useful point. You're not trying, one study doesn't have to change the world, or doesn't have to rewrite a whole discipline. If you can provide a study that does justice to what your audience knows already about the situation, which also provides one clear insight they didn't have already, you're likely to make a sale. So whether it's to journal reviewers or to your boss or to a commission considering implementation of a policy, I think this is the right attitude to take. I want to close by mentioning the Journal of Global Economic Analysis. This was just launched in 2016 by myself and Niven Winchester, and we're quite enthused about it. It builds on our very high impact GTAP technical paper series. It has several sections: advances in theories and methods, advances in data and parameters, and advances in software. We expect this will be a very useful, a real go-to journal for those in the GTAP network. In this case, the advances in theory and methods focus on the Melitz model and how that can be incorporated into the GTAP framework. Advances in data parameters, an overview of the newly released GTAP-9 database, as well as the brand new GTAP-Power database with a focus on the electricity sector. And the software here relates to extracting data in an efficient and useful way from the World Bank's World Development Indicators. So we'll hope you'll use this journal, that you'll cite it, and that it will help you become more productive. Thank you very much for your attention. If you wouldn't mind completing the evaluation, that would be useful as well. Thank you.